Hi guys, welcome to my channel. In today's video, I'm going to talk about first come, first served scheduling algorithm. It's one of the simplest and easiest scheduling algorithms. Let's understand how does this work. As the name suggests, it is first come, first served, meaning whichever job or process comes first will be given the CPU time first. For example, you go to a movie theater, you go and stand in the line or the queue to buy a ticket. Imagine there are 10 people ahead of you in the line. You can buy a ticket only when all those 10 people finished buying their ticket and leave the queue. Then only you get to your turn and you can buy a ticket for yourself. So the similar thing works here. There is a queue, there's a single queue maintained. For example, P1, process P1 comes first, it's put into the queue. Then comes another process, P2. Then comes another process, that is P3. So there are processes in a queue, single queue. Whenever the CPU becomes available, it will come and look into the queue. See, it's P1 in the first place. So P1 will be given the CPU time first. Then P2. Then P3. Here, the algorithm is non-preemptive, meaning P2 can be given CPU time only when P1 completes its work. P3 can be given CPU time only when P2 completes. There is no other way P2 can get into execution before P1 or P3 can get into execution before P2. That cannot happen. That is why this is non-preemptive. Now the advantage of this first come first served is that it is simplest of the all scheduling algorithms. It is easiest to implement. Whereas the disadvantage is it has got convoy effect. What is the meaning of convoy effect? Let's understand with an example. Your mother asks you to buy 2 packets of milk. You go to the nearby supermarket, you pick a couple of packets of milk, go and stand in the billing section. And there is one person ahead of you and he has bought the grocery for the entire month. That means that is a lot of billing to be done and you will have to wait all the time till he finishes. Here you can't ask him, hey, I just have 2 packets of milk, can I get my things billed before you? You can't ask here because this algorithm is non-preemptive. There's no way you can get ahead of him. You have to wait till the time he finishes his billing. That means you have to wait for large time, though you have just 2 packets of milk to get billed. The similar thing works here. For example, P1 needs 10 units of time for execution, P2 2 units of time, and P3 just needs 1 unit of time. Though these processes have smaller CPU time, they can't execute before P1 because this is non-preemptive and this is first come first served. They have to wait till P1 finishes. That means they will spend a lot of time waiting. That means this algorithm suffers from convoy effect. Here, jobs or processes with smaller CPU time such as P2 and P3 will have to wait for longer time because they came into the queue later on. This is nothing but the convoy effect. Now let's understand an example of how to calculate average waiting time and average turnaround time in the case of a FCFS situation. Now let's solve a problem related to average waiting time and average turnaround time calculation. Here I have 4 processes A, B, C, D and their arrival time is given and the burst time is given. Time is given in milliseconds. Let's understand, in order to know the turnaround time, we need to have the completion time because turnaround time is equal to completion time minus arrival time. Here the arrival time is given but we don't know the completion time. For that we need to use a Gantt chart. That we'll do in a bit. Before that, the waiting time, the formula for waiting time is turnaround time minus burst time. First, let's calculate the completion time using a Gantt chart. Let's draw a Gantt chart. Here we see that if you look at the arrival time column, we see that process B has come at 0. That means process B has come first. So we will put B in the first place. Here it is 0. B executes for 4 milliseconds. So it is, I will write 4 here. Then if you look at the arrival time column, 1, it is D has got 1. After B, it is D. So D executes for 2 milliseconds. I will add 4 plus 2, that is 6. Then I will have A, which has come at 3. So A is the third process, which executes for 5 milliseconds. That means 6 plus 5, that is 11. Then I have process C that executes for 3 milliseconds. So I will add 3 into 11, that becomes 14. So this is the Gantt chart. So now we know the completion time by looking at the Gantt chart. Completion time of B is 4, completion time of D is 6, and completion time of A is 11, and completion time of C is 14. Now the calculation of turnaround time becomes easier. Let's do that. Now let's calculate the turnaround time. For process B, the completion time is, we see it as 4 here, 4 minus arrival time of 0, that is 4. Turnaround time for process D is, it completes at 6 and the arrival time is 1. 6 minus 1, meaning it's 5. Then I have process A. Here process A completes at 11 and it has come at 3, that is 8. And the turnaround time for C is, completion time is 14 minus the arrival time for C is 4. Means 10. These are all the turnaround time for each process. In order to calculate the average turnaround time, we have to add these up and divide by 4. That is nothing but 4 plus 5 plus 8 plus 10 by 4. That is 27 by 4, which becomes 6.75 milliseconds. This is nothing but the average turnaround time in this case. Now let's calculate the average waiting time. Here the waiting time, the formula is turnaround time minus burst time. Burst time is given here. Turnaround time, we got them here. So now let's calculate the waiting time for each of these processes. For B it is, for B the turnaround time is 4 minus the burst time is, for B it is 4, that is 0. Then for process D it is 5, turnaround time is 5 and the burst time is 2, that is 3. 5 minus 2 is 3. Then I have A, the turnaround time is 8 and it is burst time is 5, which is equal 3. Then I have process C, which has the burst time at the turnaround time of 10, the burst time of C is 3, it becomes 7. Now we have all the waiting times here. Let's compute the average waiting time. That becomes 0 plus 3 plus 3 plus 7 by 4 means 13 by 4, which equals to 3.25 milliseconds. So we have the average waiting time here and we have the average turnaround time here. That's how we calculate the average waiting time and average turnaround time for FCFS. That's all I have in this FCFS video. I'll see you in another video. Bye.